Hello everyone. This is a continuation of the discussion on the classifications of organic compounds. In the previous video, we are already through with the hydrocarbons. In this video, I will discuss about the halogen-containing compounds and the oxygen-containing compounds. Starting with, we have the halogen-containing compounds. Organic compounds may also contain other elements aside from carbon and hydrogen. Some of these are the, the alkyl halides, where carbon atoms are bonded with halogens. So halogens are found in group 7A on the periodic table. So this includes fluorine, chlorine, bromine, iodine, and astatine. Alkyl halides are hydrocarbons in which one or more hydrogen atoms around a carbon atom have been replaced by halogen atoms. So they have the general formula of Rx, where R is any alkyl group. So yung alkyl group natin is the hydrocarbons, which includes carbon and hydrogen. And X is a halogen. So, a halogen includes fluorine, chlorine, bromine, iodine, and astatine. For example, we have here the hydrocarbon methane. So, I'm going to show you the successive substitution of chlorine atoms to each hydrogen of methane forms different alkyl halides. First, let us replace one hydrogen with chlorine. So that will become methyl chloride. Next, if two hydrogens are replaced with two chlorines, that will become methylene chloride. Then, if three hydrogens are replaced with three chlorine, that will become chloroform. And if all hydrogens are replaced with chlorines, that will become carbon tetrachloride. So the melting and boiling point of alkyl halides increase as their molecular mass rises. So methyl chloride has the least number of chlorine atoms and thus has the lowest molecular mass and boiling point among the given alkyl halides. On the other hand, carbon tetrachloride with the greatest molecular mass has the highest boiling point. In general, alkyl halides have higher melting and boiling points compared to hydrocarbons with comparable molecular masses. Alkanes, where hydrogen atoms are substituted with chlorine and fluorine, are collectively called chlorofluorocarbons, or that is CFCs. So these compounds are widely used before as refrigerants and as foaming agents for plastics. So these are known ozone-depleting substances whose uses are now being controlled and reduced. So these substances has a bad effect on our environment. That is why the use of it is now being controlled and reduced. So that is about the halogen-containing compounds. Next, we have the oxygen-containing compounds. Some hydrogen or some hydrocarbon derivatives have oxygen-containing functional groups, in which the oxygen either participates in two single bonds. We have the alcohols, phenols, and ethers. Can also participate in a double bond, which includes aldehydes and ketones. Or It can also participate in single bonds and another in double bond, which include carbocyclic acids and its derivatives. First, we have alcohols. So alcohols are compounds that have a hydroxyl group. So hydroxyl group has oxygen and hydrogen. So that is OH bonded to a carbon. So they have the general formula of ROH. So R is any from the alkyl group and OH is the hydroxyl group. So alcohols are named by appending the suffix OL to the hydrocarbon name from which it is derived. For example, we have methane. So methane becomes methanol, which is an alternative engine fuel. Similarly, we have ethanol, which is derived from ethane. So this is used as a disinfectant, wine ingredient, and a fuel. Next, phenols. So phenols are similar to alcohols except that the hydroxyl group is attached to a carbon of a benzene ring. So the simplest example of a phenol is monohydroxybenzene. So this is also known as the phenol. So this is used as an antiseptic and a raw material for making plastics and aspirin. Another example is the hydroquinone. So hydroquinone is a skin bleaching agent in personal care products. So usually makikita mo to sa mga rejuvenating toners. Next, we have the ethers. So ethers are compounds with the general formula R, O, R prime, where R and R prime are hydrocarbon groups which may be the same or different. So an example of ether with similar R and R prime is diethyl ether. So this is a similar because as you can see from the left and right side of the oxygen has the same composition. So diethyl ether is used as an organic solvent and sometimes as anesthetic. So it is named diethyl because it indicates the two ethyl groups attached to the oxygen atom. So we have an ethyl to the right side of the oxygen and another ethyl on the left side of the oxygen. So the last name, ether, is a standard term for all ethers. Next, we have the aldehydes and ketones. So aldehydes and ketones both contain the carbonyl group. So carbonyl group is a double bond between the carbon and oxygen. Aldehydes are named by replacing the terminal E of the corresponding alkane name with Al. For example, we have methanol. So methanol is the corresponding aldehyde of methane. So methanol is the simplest aldehyde and is usually available as 40% aqueous solution known as formalin. So formalin is used to preserve biological specimens. On the other hand, ketones are named by replacing the terminal E of the corresponding alkane with ONE. For example, propane is the corresponding ketone of, propanone is the corresponding ketone of propane. So, propanone is commonly known as acetone. So, this is a solvent for plastics and a nail polish remover. And lastly, we have the carboxylic acids. So, carboxylic acids contain the carboxyl functional group. So, they have the general formula of, so we have R and the carboxyl group. So, the highlighted part of the image is the carboxyl group. So, that is the combination of the carbonyl group and the hydroxyl group. So, the carbonyl group is the double bond between C and O. And the hydroxyl group is the OH. So, joining them together, that will be the carboxyl group. So, simple open-chain carbocyclic acids are named by replacing the terminal E of the corresponding alkane name with OIC and adding the word acid. For example, we have the methanoic acid and the ethanoic acid. So, which are the derivatives of the alkanes, methane, and ethane respectively. So, ethanoic acid is commonly called the acetic acid. So, this is an ingredient of vinegar. On the other hand, methanoic acid is an acid secreted by ants. So, this acid causes the sting in their bites. So, those are the halogen-containing compounds and the oxygen-containing compounds. Thank you for watching, and I hope you have learned something.